cooking. There we go. Nailed it. Okay, so we use Adam in here, and we're writing merge sort split, correct? All right. And what did I say? Keep splitting until it's a one list, and when it's a one list, say there's nothing to do. Otherwise, get to the point where you should do the merge and maybe say something like, merging from begin to end, something along those lines, so we can kind of see the portion of the list that we're working with. Okay, so it's okay. Let's just clean our world out here. So I'm going to go ahead and let's just give ourselves a list. So we'll call this guy numbers, and we'll set this equal to random order. So we'll say 3, 17, 2, 1, 8, 14, 7, something like that. All right. Then we're going to go ahead and for no good reason I had a space up here. Then we're going to go ahead and we're going to write our merge sort. Well, first, let's just print out numbers down here. Just make sure everything is zigging instead of zagging. So we'll go out to our terminal. I really dislike this keyboard. All right, so there's our unsorted list. So it's finding the right file, all that crap. All right, so now let's go ahead and we're going to write a function for merge sort that's going to do our merge step. So we'll say def. Now I'm actually going to show you something I mentioned out loud last time, but I'm just going to do it as a couple of steps here. So I'm going to have merge sort be the name of a function here, and this guy's just going to take in a list. And then I'm going to have another function here called merge sort helper or something like that. That's going to take in a list, a begin, and an end. Okay? And what merge sort's going to do is they're actually going to call merge sort helper passing the initial begin and end. That way the user doesn't have to say, well, the begin is 0 and the end is the length minus 1. Okay, we'll have our merge sort function do that for us. So all the user has to do is call merge sort passing the list, and then it figures out the initial call to merge sort helper. Does that make sense? So we'll go ahead and we're going to say merge sort helper passing on the list that was given to me, passing the initial begin, which is 0, and then passing the initial end, which is the length of list minus 1. Make sense? So we're just letting merge sort make that initial call to merge sort helper for us with the correct begin and end to get the ball rolling. This is more of just a benefit for the end user to not have to randomly throw in a couple of numbers that they might not know that we want it to be 0 in the last legal bucket versus the last bucket beyond it or something like that. All right, so really what we're doing here is we're writing merge sort helper. This is the guy that determines if something is a one list. If it's a one list, we're done. Otherwise, we do our splits, right? All right, so merge sort helper. We're supposed to ask the question, is this trivially sorted? What does it mean for it to be trivially sorted? It means that end and begin are the same value. We have a one list. Okay, so if it's not a one list, what do? We call merge sort on the first half. We call merge sort helper on the first half. We call merge sort helper on the second half. And then we do the merge step. Otherwise, we just say it's sorted, do nothing. So we'll ask the question, if begin is equivalent to end. If this is a one list, we'll go ahead and print out already sorted. Something like that. Maybe we do one list. Else, we want to call merge sort on the first half, merge sort helper on the first half, and merge sort helper on the second half. Okay, So we'll go ahead and calculate middle, and middle is going to be end plus begin. Divide 2. Double divide. See, I almost made the mistake again, but I didn't. See, I'm still learning. All right, so we'll calculate the middle position. Now we get to decide, is middle the end of the first half or is it the beginning of the second half? Doesn't matter which choice we make as long as we always make the same choice. All right, so we're going to go ahead and we're going to call merge sort helper, passing it our same list, passing it our same begin, and let's have it go middle minus 1 for the first half. Then we'll call merge sort helper, passing it our list, passing it middle as the beginning of the second half, and passing it end for the end of the second half. So this is calling merge sort helper on the first half of the portion of the list I'm looking at. This is me calling merge sort helper on the second half of the portion of the list we're looking at. Then, once both of those guys return, we'll say time to merge I could do this in Python 3, right? Begin to end. Oh, that's right. Won't let me concatenate them like that. I can concatenate with the plus sign, but I can't, it won't allow it to work without a string. So I'm just printing out a word here, or printing out a sentence. Time to merge. This might be 0 to 4, or something like that. Okay? That should be the homework. So let's go ahead and test this guy. Now, what we should see here, and we're actually going to see the stopping points. I'll insert the stopping points here, but if we think about this initially, it's going to pass in this first list. Okay, that guy is not going to be a 1 list, so it's going to call merge sort in the first half, which is going to take us to there. Merge sort in the second half, which is going to take us to there. Go ahead.
On line 3, is that comma placement going to affect that at all? That's not the first and the second one. It's just.
Oh, it won't make a difference.
It's not consistent.
It won't make a difference. Yeah, it's fine. Yeah, in fact, you can run these all together if you want.
I know you can.
But it's a good question. Yeah, it's a good question. It won't matter where it's at, but it is a legitimately good question because it looked weird to you.
It was not your norm. But I figured.
Well, see, this was one of the situations where you introduced something a little awkward, hoping somebody caught it. So you start. No, yeah, of course, I do everything that's wrong on purpose.
Well, you also blame the keyboards. It was probably it wasn't your fault. The keyboard, because you said like a minute before you typed that the keyboard sucks.
Yeah, that's a little foreshadowing. See, this class is a story.
You gotta pay attention.
One time I was, I don't remember which class it was, but the class let me write in the wrong language for, it must have been 15 minutes.
No way.
Well, I mean, on a given day, I might program in, like yesterday, I programmed in Python, Java, and Swift last night for 4.5 hours. So on a given day, you program in different languages. It's no different than you're speaking English in the morning and then German and then Spanish or something like that. And you get into really, it might be if you're like a foreign student that, I mean, so back there, you might speak English with somebody. He's probably chatting in. Who's sitting there? He's chatting in Chinese right now, right? You guys are just talking Chinese, right? See, Chinese. But now he's talking English with me. Well, he's not saying a whole lot, but he knows that we're. So that's 2 out of 3 languages right there. Do you know any other language besides English and Chinese? A little bit of Japanese. Do you speak Japanese with anybody on a daily basis? Oh, so you watch anime. Which is in Japanese, and you understand what's going on. Okay, and that happened. You watch it often?
Yeah.
See? 3 languages one day. Nailed it.
So what language were you writing in? In what language are you supposed to be?
Yeah, that's a good question. I don't even know. Next semester, it gets even worse. Next semester, it's 5 languages in a single day. So next semester, I'll be teaching in C++ as well as Scheme. Yeah, for our programming language theory class. So it's fun. Yeah, it's not as bad as it sounds because if you go back to, I mean, this is really part of this course still. Remember the first couple weeks I talked about programming is programming. The language doesn't matter. Same thing with the spoken language. I mean, when those two are chit-chatting back there, they're converting their mindset to the Chinese language mindset, but they're still talking to a person. He's saying the same stuff to him as he might say to me. Just because they both speak a same common language, they're choosing that language because you're more comfortable with it, right? When he's talking to me, it's not his native tongue, so it's going to make some stuff up, right? And when he doesn't know what to say, he just kind of makes a weird noise and hopes I didn't notice, right? That's what I've been doing this for a while. The Indian students all do that. That's just how the American students do that. All right. So we'll go through here. So what should happen in this list? The very first time we come through, we'll ask the question, is begin and end equal to each other? It's not. So we'll calculate a middle. We'll call merge sort on the left, call merge sort to the right. So this is the original call to merge sort on the left. Is that a one list? No. Call merge sort on the left, call merge sort on the right. This is the call to the left. So we're going to see already sorted, one list. Then we're going to get to our merge sort to the right. Then we're going to get to our merge sort to the left. Already sorted one list. Then merge sort to the right. Already sorted one list. Then those two guys have returned, so we're going to say time to merge 1 to 2. Then this half is going to be done. Then it's going to make our initial second call. So this is the original second call here on this half. Is that the one list? No. Call merge sort on the first half. Is that a one list? No. So already sorted one list. Already sorted one list. Time to merge. What's 0, 1, 2, 3 to 4. Then we call merge sort on the second half. One list. Time to merge. 5, 6. And then we're done. So that's what the output of this guy should ultimately be. So we'll go ahead and we'll call merge sort helper down here. We'll call merge sort. Passing it are what I named my list, numbers. Passing it numbers. So actually with that in mind, I'm going to just move this down by the call because we're not using it as a global variable right now. We just need it. I'm passing it in. So we'll call merge sort on numbers. Merge sort will take that list, go ahead and pass it to merge sort helper, passing in numbers, the beginning spot, and the last legal bucket. It prevents me from having to do this myself. Merge sort helper 0 to length of numbers -1. It keeps the user from having to come up with that beginning and end thing. It's not a problem. It's not a big deal. Yeah, I'm more just thinking about this from a convenience perspective. If you're creating a library to let somebody do merge sort, make it as easy for them to call as possible, right? When you go to Home Depot and you have 2 choices of a tool, one of them is very automatic, just pick up and use. The other one takes some setup. You might choose the automatic one if the price is the same, right? So it's really just that. Who? Am I allowed to? No, I mean, you're not allowed to, but I have an in with Gretchen.
Oh, I got you.
Yeah. So I'm kind of above the law. So they have to catch me. Well, they have to catch me and tackle me. I have incredibly mediocre foot speed. Well, I am difficult to tackle. Okay, because I'm a biter. That's what All right, so let's see if we get what we expected to get here. Row. Maximum recursion depth exceeded in comparison. So, more than likely, what have we done? We've introduced an infinite loop. Okay. Remember we talked about going into the stacks, right? So every single time we put it on hold, it keeps putting the thing on hold, putting the thing on hold, putting the thing on hold. So this is saying, look, you've put enough stuff on hold.
You do this just for Aaron
Huh?
because it's a loop. You do it just for
Yeah, it's well, it's not really a loop. It's recursion, but it's like a loop.
I think we should make an infinite recursion sound.
All right, so we got our originally already sorted one list here. So let's see where we went south. So we made our initial call from 0 to, this is what, 7 minus 1, 6. So this is the last legal bucket is 6. So we called in on our list 0 to 6. Is 0 and 6 the same value? It's not. So we'll calculate middle. 6 plus 0 is 6, divided by 2 is 3. So middle is going to be 3 in this particular case. So we'll call merge sort helper on 0 to 2 for that first half. Okay? Let's pause that for a second because we're not getting to this line yet. We're waiting for this one to finish. So we'll come back up. Is 0 and 2 the same number? They're not. So we'll go ahead and we'll calculate middle. So that's 2 plus 0, which is 2, divided by 2, which is 1. We'll call merge sort helper on 0 to 0. Left half. That make sense? So 1 minus 1 is 0. So this is 0 to 0. Spin back up. Is begin and equal to end? Is 0 equal to 0? It is. So we'll print out already sorted one list. And we got that guy right there. All right. So far, so good. So we finished that call. Now we get to our second call here. And that is the call where we had the first half of our list. This was 0 to 2. That's the first half of the list. Now we're going to call it on bucket middle to end, where middle was 2 plus 0 is 2, divided by 2 is 1. So we're going to have 1, 2, 2. That's what we're calling it in there. Is 1 and 2 the same number? They're not. So we come down here. 2 plus 1 is 3, divided by 2 is 1. So that's going to be our middle. Okay? So we'll call merge sort on our list from 1 to 1, because we were looking at 1 and 2 here, right? This was the second half, that first call. So our first half is 1 to 1. Actually, 1 to, that's actually our problem. 1 to 0 is where we ran into issues here. So this call here, we were calling merge sort from, we're going from bucket 1 to bucket 2. That's the portion of the list we're currently looking at. They're not the same values, so we need to go ahead and calculate middle. Middle is 2 plus 1, which is 3, divided by 2, gives me a 1. Okay? So now I'm going to call merge sort helper on bucket 1 to 1, the first half of that. Everything, or actually 1 to 0. They've overlapped each other. Does that make sense? Middle I calculated right here. Middle was 2 plus 1, which is 3, divided by 2, which gave me 1. So the middle is going to be 1. I decided that the end of the left half will be middle minus 1. Okay, so that actually is 0. So when I call this here, I'm calling merge sort on begin, which is 1, to 0. Problematic, right? Okay, so they're not equal to each other. They've actually overlapped each other. But we know that's still a 1 list. So really our test for a 1 list here, we need to say if begin is less than or equal to end. That means we're dealing with a 1 list because we do have that situation where you could have an overlap. That make sense? So our test for a 1 list can't just look at them being equivalent. That is usually going to work, but depending on the number of elements in our list and how we're dividing things up, we might get a situation like we had right here because we're choosing to say the end is middle minus 1. If we said the end was middle and we said middle plus 1 here, the problem would still exist, but it would exist on the other side for the right half of the list. where middle ends up, where begin ends up being greater than end. So we need to say if begin is less than or equal to end, we have a one list. We have overlap. So that's sorted. Otherwise, let's do some splitting. All right, so we got already sorted one list there, but it ended. So we call merge sort helper. Let's write out each call, just so we can debug this. So I'm going to put some comments down here. So we have our original merge sort helper on our list, passing it 0 and passing it 6. That's our original call, correct? And is begin is 0, less than or equal to, oh, sorry, if begin is greater than or equal to end. That's when we have the one list. So I said the right thing, but I wrote the wrong thing. Otherwise, this was trivially over, right? The very first time we came through here, if I'm saying is begin less than or equal to end, well, is 0 less than or equal to 6? Yeah, done. There's our answer. All right, so that's not going to fly for us. So we want to say it's a one list if begin is greater than or equal to end. Let me run this real quick, and then we'll still walk through it just so you see it. Okay, so we're going to still have to debug it anyway. So merge sort helper list to 0 to 6. Is begin greater than or equal to end? Is 0 greater than or equal to 6? It's not. So we go into the else. We calculate middle. Middle is going to be 6 plus begin, or 6 plus 0 divided by 2, which is 3. Then we call merge sort helper, passing it the list, passing it the current begin, which is 0, and passing it middle minus 1, which is 2. Right? We're also going to be calling merge sort helper. I'm going to give us a little space here because our second call is not going to happen yet. Okay, but we will be calling merge sort helper on our list from 3 to 6 for the second half. But we don't get to that until this guy has finished. So we're going to go and work on that guy for a few minutes. So that's what we're doing in here. So we have our call to merge sort helper passing at list 0 to 2. Is 0 greater than or equal to 2? It's not, so we don't have a one list yet. So we get into the else. We calculate middle. Middle is 2 plus 0, which is 2, divided by 2, which is 1. So we're going to go ahead and we're going to call merge sort helper on the list from bucket 0 to bucket 0. That is from begin, which is 0, to middle minus 1, which is 1 minus 1. All right, so there's merge sort helper on that guy. All right, and this guy should then give us our already sorted one list. That guy should give us that answer, correct? And I think we saw that. Now we're calling merge sort helper on the right half of our list here, which is from middle, which is 1, to end, which is 2. All right, because middle minus 1 here, just middle here. So 1 to 2. Is 1 greater than or equal to 2? Go ahead.
How does Python know to skip past the first call to merge sort helper? Wouldn't it just continuously call the first merge sort helper repeatedly?
This guy?
No, the part up above. In the else statement, how does it know to go to the next part?
It doesn't go to the next part yet. That's why this is our original call to the second part. See how I keep pushing it down the list? It hasn't happened yet. It is on hold. So this guy has not happened. This is a promise down here that we're eventually going to call this, but we haven't actually made that call yet because we have to wait for this original one to finish unfolding. All right, so we're building out those guys here. So we finally ended this one. So we can put a little X here at the beginning. That guy's complete. Okay, he's finished, and we got our printed result. So no more recursive calls out of that guy. Now we're in our merge sort helper from our list 1 to 2. Is 1 greater than or equal to 2? It's not. So we'll come into the else. We'll calculate middle. We'll say 2 plus 1 is 3 divided by 2. 2 goes into 3 one time. So no, it has a remainder, but we just get the 1 out of it. So now we'll call merge sort helper. Let's steal this line. From 1 to middle minus 1, which is 0. Right? We ask the question, is begin greater than or equal to end? Is 1 greater than or equal to 0? It is. Already sorted, 1 list. We should get that guy. And then this dude is complete. Okay. Then we make our second call to merge sort helper here. Yeah, so really if I'm staying consistent here, I'll go ahead and take this guy off for right now because I'm not writing that promise in for any of these other ones. So we'll say merge sort helper on list. So this is our second call from here. This is from middle plus 1, which is, or just middle, which is 1, to end, which is 2. Actually, this was this guy here. So this is 1, actually this is where the problem is going to be. So 2 plus 1 is 3, divided by 2 is 1. So we're calling merge sort on, we're doing this stuff right here over and over again. That's where our loop is right now. Just notice we had a call merge sort 1 to 2 right there. And we have the same thing right here. So let's actually switch this to middle and middle plus 1. So that'll be 0 to 6, then 0 to 3, and then this will be 0 to 2, which we're not already sorted yet. Let's just go back here for a second and see if we run into that same problem. So we'll originally call it on 0 to 6. 6 plus 0 is 6, divided by 2 is 3. And we're going to go ahead and go all the way up to middle for the first half. So 0 to 3. Then we have 3 plus 0 is 3 divided by 2, which is 1. So we'll call merge sort on 0 to 1. Is that the 1 list? It's not. So we'll say 1 plus 0 is 1 divided by 1 is, have the same issue here. No, divided by 1 plus 0 is 1, divided by 2 is 0. So we're fine. So this would be 0 to 0. Those guys are, is it greater than or equal to? It is. So we're done. So that guy ends. Then we'll have our call to the second half, which will be middle plus 1, which is 1 to 1. That guy will end. Then we'll come back and we'll call the second half to this guy, which is merge sort on middle, which was 1, so it's going to be 2 to 3, which we'll then call merge sort on 3 plus 2 is 2. No, 3 plus 2 is 5, divided by 2 is 2. So this will go from 2 to 2. They're the same, so that'll be done. Then we'll call merge sort on our middle, which was 2, to 3. Actually be middle plus 1, so 3 to 3. That guy's done. All right, so it looks like we're not getting into the loop this time. So we'll keep going with this. So that's done. So these were the two recursive calls from this guy. So then we're going to see this guy will get done because his two calls have finished, right? So we'll get the time to merge. Then we'll have the second write call here. So now this guy will finish, which will then allow, that'll be the second call, which will then allow this guy to finish, which then means we need to do the right half of this call, which will be from 4 to 6. So now we're finally making our call. So this kind of goes to what you were saying. We're finally making our call to the second half of the original list. After all this work, we're finally getting to that guy. That make sense? So 4 to 6, is that a one list? It's not, so we'll call merge sort in the left half. Which is going to be 6 plus 4 is 10. 10 divided by 2 is 5. So this is going to be 4 to 5. Is that a one list? It's not. 4 to 5, so that's 9. 5 plus 4 is 9. 9 divided by 2 is 4, so we'll do 4 to 4. That's a one list, so we're done. Then we'll do 5 to 5. That guy's done, which then allows this guy to be done, which then means that we need to make our second call for this guy. So we went from 4 to 5, so now we're going to go from 6 to 6. That's a one list, so that guy will be done, which then lets this guy be done. And now all of them are, which then finally lets this guy be done. So all of them are now done. Okay. So now interesting thing here, let's see, for one lists, these were the same. These were the same. Same. With this logic, we never have an overlap, which means we can actually say begin and end are the same. Choosing middle here and middle plus 1 here. So there's our answer. See, that's interesting. I hadn't, our original solution would have worked if I had an even number of elements in my list. Making that choice of going to middle for the original end and middle plus 1 for the second begin was an important choice for an odd number of elements. So with that in mind, I had previously advertised that, oh, it doesn't matter how you calculate middle as long as you always do it the same. You can make that a true statement if you do the correct checking up here. But this is the path of least resistance to pull this off. When you calculate middle, we're still calculating middle the same way we did even for binary search. But then when we go and do this, the end of our first half, we choose to be middle, and this actually has to do with the fact of an earlier decision that we made. And the earlier decision that we made is that end always represents the last legal bucket of the portion of the array we're currently interested in. If we had decided that end was one off the end, then we could have done middle the other way. Okay, so choosing the semantics of end here, what we decided that variable would represent, drove our decision down here for how we needed to use middle for doing this. Now, we're gonna call this a pretty short list that we're sorting here, right? Would you admit that for a pretty short list, that is a lot of calls? I mean, that's hard to kind of follow, correct? Okay, in truth in advertising, I said you're not going to like this. Okay. Now, when we finished writing this, this wasn't all that difficult to finally write. But we introduced a bug at the beginning here, and I actually didn't do this one on purpose. I had forgotten about what we had the meaning for this, so then this becomes important. But it ended up being a good learning experience anyways. But the point is that even me having done this for a while, you can still run into bugs like this. And then we saw that tracing this out was kind of confusing, is probably a fair statement, right? I mean, we're saying the same thing over and over again, just dealing with different portions of the array. Does that make sense? Okay, so, with that in mind, it's a little bit hard to debug recursive stuff because of the kind of the nature of it. Now, what we're going to do is we're going to expand this a little bit. I'm going to give myself a little another function that will print out an array just from a specific area of the array, right? Just so instead of me saying time to merge this guy, I'm going to go ahead and I'm going to print out what part of the list we're currently dealing with. All right. So I'm going to give myself a function called print list part. This guy's going to take a list and a begin and end. And what he's going to do is he's going to go through and he's going to display the portion of the list that we are currently working with. Okay? So in order to do this, I'm actually just going to build a new list. That way it'll end up looking like a list, since we know when we print a list, it gives us the nice little square brackets. So I'll go ahead and just give myself a temp list. We'll start this guy off as the empty list. And then I'm going to go ahead and I'm just going to say for I in range of begin to end plus 1, because I want it to go all the way up to. We know that our end is inclusive. We actually go to that position. All right? And this range function says go to this value but non-inclusive. So I'm going to go 1 plus that, which will get me to that value. And then I'll go ahead and say temp list dot append list at bucket I. And then I can go ahead and print out temp list here at the end there. All right, so this will allow me to see the portion of the list that we're currently dealing with. Okay? So I'm going to go ahead and right at the very beginning of each call to merge sort helper, I'm going to do print list part, passing it the list begin and end. So we can see what it's about to ask all these questions about. And we can see how it reacted to each one. Okay? So let's go ahead and just run this one more time. We're just showing our list as we go through, which will kind of break up our code a little bit. All right, so here's our original call. We're originally processing that guy. Did nothing. We went to the else. Here's the left half of that guy. Here's the left half of that guy. Here's the left half of that guy. That's a one list. Here's the right half of that guy. He's a one list. Then we have to merge 0 to 1. So that is, we're merging that list after we've gotten the 2 1 lists out of there. Then we're dealing with the right half of this guy, 2 to 1. Then the left half of him, 2, there's our 1 list. The right half of him, 1, there's our 1 list. Then we're going to do time to merge 2 to 3, which is we're merging this guy. Then we're going to merge 0 to 3, which is that guy, after they've returned. Now we're dealing with the original right half, this guy right here. then the left half of that, then the left half of that. There's our one list. Then the right half of that. There's our one list. Then time to merge. Full bucket 4 and 5. Now we're dealing with the right half of this list. There's our 7. That's a one list. Time to merge, 4 to 6. This guy right here. Time to merge, 0 to 6. This guy right here. And then we're done. Does that make sense? How we're visiting each of those steps, how we're breaking it apart. So now we're kind of visually seeing what we wrote right here. All these merge sort calls. Now, what's interesting here is that's the, I'm going to say, the relative easy part of merge sort. Now, the good news for us, and the reason I set this up this way, is notice how I'm saying time to merge 4 to 6, or 0 to 6, or 4 to 5. When we do that merge step where we kind of say, who wins, this guy or this guy, pick the winner. Who wins, this guy or this guy, pick the winner. And then we have our list of winners here. But then I need to copy those guys back into the buckets of our original array. Now I know where I'm copying them back in. I'm copying over buckets 4 to 6. I'm copying over buckets 0 to 6, buckets 4 to 5, buckets 0 to 3, buckets 2 to 3. So I have the begin and end values of where I'm ultimately going to copy my sorted part array back into the original, which should make the merge step significantly easier to write. So what we're going to need to do in here, after this time to merge thing, is we want to go ahead and create a temp array of size well, if we have end is 5, begin is 4, we really need it to be 2, so it would be end minus begin plus 2. End minus begin plus 1, sorry. So big enough to hold all the numbers in the part of the array I'm working with. Do the merge step, storing solution in temp array. Copy temp array over the values in original array from position begin to end. So for your homework, you're doing that part right there. That make sense? Huh? You can keep it in there, or you can call a new function. It doesn't matter. Yeah, if you find a new function breaks it up better for you, that's okay. All right, so I'll go ahead and I'll give you all this code as your starting point, and that should give you a decent jump at doing this. So don't overthink this. All you're doing is working off of 2 lists from beginning to end and beginning to end, and you're saying who wins, this guy or this guy. All right, copying, appending the answer here. Who wins, this guy or this guy? Appending the answer here, so you get all your answers. Then you copy that back into this portion of the original array. We're not doing sorting stuff. We're just doing that little merge step that happens to be part of the bigger picture of sorting. All right, I will see everybody on Friday.